Welcome back, ladies and gentlemen, and Tedo, because Tedo is non-binary. Anyways, in today's video we are going to solve a functional equation from a random country which is chosen by this site, and our country is Uruguay, and we have Uruguay here. We have only two contests. Okay, we have function equation here. Actually, I think I have solved this one. Yeah, this is my solution. Okay, we have to choose another one. Okay, I don't know this problem. Okay, let's copy this. Okay. To start off, I will put zeros, of course. f0 is equal to f0 squared. So let's call f0 c. So we have fc is equal to c squared. Okay, now can we prolong activity? No, not so easily. Let's try this. Maybe we will get f(x) is equal to fx squared. From here we might suspect that fx is equal to fx x squared. So our guess should be fx is equal to x squared. But how can we prove that? We can try like this. Fx minus x squared is equal to c times fx, and we can try. Okay, if we put so let x be equal to c, so we get fx, we know that fc, we know that is equal to c squared, so we get c squared minus c squared, which is 0, and f0 is c, so c is equal to c times fc, which is c squared, so we get c cubed, and we have c is equal to 0 or plus or minus 1, and if we put c equal to 0, so case 1, c is equal to 0, so we have f0 is equal to 0, and if we put this, we get actually nothing, but we can try like, okay, from right here we put this and we get that this is 0, so we know that f fx minus x squared is equal to 0. Okay, and so we have like infinitely many, or at least one a such that such that f a is equal to 0. We know this. So if we put like this, we get f a y is equal to 0, and if a is not equal to 0, we can replace y with y divided to a, and this implies that fy should be equal to 0. And of course this is one of the solutions, so we can like underline. Okay, so we have one solution. But if a is equal to 0, then we have fx minus x squared is equal to 0, which implies that fx is equal to x squared. And this is one of the solutions also. Okay, so we have two solutions already in case 1. Now case 2 is c equal to let's call this 1. Okay, if c is equal to 1, we have f1 is equal to 1 simply, and we know that fx minus x squared is equal to fx. Okay, and nothing else, but we can try like this. Actually f1 can be equal to 1 because fx is equal to x squared, so this might be a valid solution. But let's try this, and we will get f2 is equal to f2. Okay, nothing useful. We can try like okay, it's interesting. If f minus 1 is equal to 1, then this is minus x. This is they are both equal. Okay, Uruguay. Which problem is this? This is problem 2. Okay, this shouldn't be really hard, but okay. What we can do here to escape this trap? I mean, it would be like nice to have injectivity, because if x is 1, we get y plus 1, and they are same. X minus 1. we can try to force these two be equal, and if this is true, then we get fx should be equal to 1. Okay, let's solve this for y. We get uh, y times x minus 1 is equal to x minus fx. Now this means that y is equal to x minus fx divided to x minus 1, and we can't force 1 to be x to be equal to 1, so we have x is not equal to 1, and if we put y equal to this, we will get fx is equal to 1 for every x, for every x except 1, but at 1 we know that f1 is equal to 1, so that's that means that if fx is equal to 1, we can mention that f1 is equal to 1, so fx is equal to 1 for every x including 1. We have this, or there's a second case, which is if x plus y is equal to 0 for that kind of y, and this is equal to f. Actually, we proved that if some t is equal to 0, then is it true that t is always 0? I mean, I think it is, because if we put this, we get this is 0, so f ty equals to 0, and yes, this is this case right here. Okay, so if there exists t such that t is 0, then t must be 0, so we have that x plus y should be 0, so we can simply say that this implies that x is equal to minus y, and minus y is equal to fx minus x divided to fraction x minus 1. Okay, now from here we have that fx minus x is equal to x squared minus x, and this means that fx is equal to x, and we are done with this case because we got fx is equal to x squared, actually, like this. And now we have last one case, case 3, if c is equal to minus 1, and if this is true, then okay, so that it would be easier to understand. If c is equal to 1 minus 1, then we have f minus 1 is equal to 1, and what we can try here, wait, can we try the same method as here when we forced this? actually we can try that. So if this is equal to 0, then we are done, and if not, we get fx is equal to 1, and that's it. We don't need all these cases. So this case simply implies that fx is 1 for every x, and we are done, I think. Yeah, that's it. Underline. So we have three solutions: fx equal to 0, which is true, fx equal to x squared, and fx equal to 1. And that's it. We are done solving this problem.